Welcome to the module CS 5024, Theory and Practice of Advanced AI Ecosystems. I am the module coordinator, Tiziana Margaria. I'm a professor of software systems here in UL. I'm also a principal investigator in LIRO, which is the SFI Research Center on Software, and of Confirm, which is the SFI Research Center on Smart Advanced Manufacturing. I have quite some experience both of industry and academia and research and practice. And so that's why the module is called Theory and Practice of Advanced AI Ecosystems. So in this welcome video, I wanted to spend a couple of minutes just explaining to you, first of all, the title, which may seem complex in the sense that there are so many keywords that appear in there. And then a little bit, something about the module, how we are going to run it, and the first activities that you should do, okay? So let's start from the end, as usual. The most important concept in the title is actually that of ecosystems. We are talking about systems of ecosystems and software ecosystems. The idea is really coming from the community of software ecosystems, which has to do with platforms and tools and the infrastructure of the software domain or the system domain, if you add also cyber physical systems, Internet of Things, smart manufacturing, Industry 4.0, and all these application domains that are growing in importance actually in the last 10 and plus years. We have in the ecosystems, we have an advanced collaboration of various components, various parts of the ecosystem that are typically heterogeneous, for instance, because of different technologies. They are typically interdisciplinary because there is some part that is software, some part that is maybe telecommunication, healthcare, or other application domains. They are also typically evolving and adaptive. Okay, so they are evolving. It basically means that, well, they are composed of different system, software systems, and with that comes actually all the evolution of the single layers and technologies. You change version of Java, version of Python, new interpreter, new release of something. Well, if you have a complex conglomerate that has actually to work very well with each other, you have the possibility of things that actually don't fit anymore well, and therefore you have an integration problem, and you have an interoperability problem, and you actually have a problem for what is called the digital thread, okay? There should be actually a digital communication infrastructure underlying the tools, underlying the applications, and basically guarantee the correct functioning, so to say, of a complex application. If something is not compatible anymore, that's a big problem. The adaptive part is basically, okay, you would like to maybe to change something over time, right? Or you would like to have it responsive to the environment, for instance. And so basically that means that not only things need to be statically correct and fit with each other, but you have to bridge across differences of technologies, communities, etc., etc., and you have to deal with change, okay, change over time. So that's for the advanced ecosystems. AI, okay, AI doesn't come just with one technology. It is always a problem of dealing with data, dealing with input, producing outputs. So you have the data science and management cycle in there. You also have different technologies, different application domains. So if you just go back to what we have seen probably in the previous modules, you have dealt with computer vision, you may have dealt with some text processing, you have dealt with applications maybe in data from healthcare or from finances or so. And you've dealt, of course, with different technologies, deep learning, constraint programming, probabilistic programming, neural networks, all these kind of, let's say, technologies that, of course, are different and heterogeneous. Not only you want them to work, they also should be compliant. They should have high quality, okay, of prediction, for instance, or classification or selection, but they also should be compliant to some kind of regulations, for instance, GDPR. They should be secure. They should preserve trust. They should guarantee privacy. And so it is not just the computation itself, but again, all this layer is part of the ecosystem around it and contributes to the complexity and heterogeneity. Okay, so software engineering is actually programming not only in the large, but it is also programming in the diverse. Okay, so the addressing of complexity is one of the topics that we have in software engineering, advanced software engineering. Now, what remains is theory and practice. Okay, so in the theoretical part, which is going to be very simple, we just reduced it, okay, to the minimum necessary in order to be able to understand properly the practice part and then to carry it out at an excellent level of proficiency. We are going to deal with concepts, okay? So the first concept that you're going to see in what we call the theory 1, there are theory 1, 2, and 3, so there are 3 sections there. We are going to talk about systems, what is a system, about the software development life cycle. Some of you are fantastic software developers and have a lot of experience, so you're going to just, go very quickly through this, and just it will be a refresher. For some other students, participants, maybe it is the first time that they hear about this, so it could be interesting. So we just recapitulate the software life cycle. Then we talk about models, because if you deal with advanced complex ecosystems at the programming level, it is a maintenance nightmare, more or less. In normal development, testing covers more than 50% of the costs and the time. If you go in integration and evolution of systems, testing and validation at the end is over 80%. Okay. If one works with models, which have been around for a long, long time, and meanwhile they've got a new refresher, so to say, in the name, they are called low-code environments or no-code environments. In these environments, actually, models of what the software does, of how the software is organized, they are themselves the main artifact of the design and development. And then there are code generators that basically transform these models, as long as they are sufficiently precise and sufficiently informative, okay, into code. And because one has compilers, one can also compile, so to say, that code to different platforms. And so it is a level of virtualization and a level of portability that is added, okay, by using models. So we are going to look at that. We are going then to concentrate on specific technologies. One technology is what we call XMDD, Extreme Model Driven Design. We are going to have a video on that, so I don't start okay, explaining you what it is. We are going to choose one category, one group, so to say, of formal, executable formal models, which are the service logic graphs, SLGs. And then we are going to use as components, as units of functionalities, basically microservices that are called for historical reasons of their origin in the telecommunication domain with this kind of technologies, with this kind of denominations, so to say, service logic graphs and service independent building blocks. They are called SLGs and SIMs. Okay. Hopefully enjoy. Bye.